but just addition or subtraction. And the reason why addition or subtraction is the easiest one to start with is because when you're combining terms that have the same exponents, you're only doing math on the number up front. The exponents don't change at all. So today's lesson is going to be the easiest. So right up here on this first sentence, what I want you to write is this. When dealing with exponents, okay, like terms have the same base, or the same bases, with the same exponents. So it's not enough just to have the same base. They all have to have matching exponents as well in order to be like terms. We cannot add or subtract when this isn't true. Do you need these? So if you're looking at the I will statement right here, this is what we should be able to do correctly by the end of the lesson. Who feels you could already do number 1? Right? 5a plus 7b plus 10. Okay. What do you remember? What's up with number 2? Why is that different? Right. They have the same base, right? The base is p, but the exponents are different. How do we handle something like that? Oh, it's a mystery? Ah, okay. You can't even do it, right? So, but we'll talk about that. It's at the end of our notes, so we'll talk about that in just a second. So what I want you to do right now, though, is take a minute here, and I want you to draw lines between the like terms. Okay? Draw lines between the like terms. You're trying to find things where not only are the variables the same, but the exponents on them are exactly the same as well. So you're matching. Right? So take a minute and do that. Right here, you're drawing lines that match the like terms together. Volunteers. Just for this section, right here. Just this section. Just drawing lines to match the like terms. Okay, perfect. Thank you. Whose lines match Gus's lines? Is that what y'all matched up? Okay. So all we're going to do now in the next section, the terms that you matched up, we're going to combine them now. We're going to actually do the addition or subtraction or whatever it is. So for example, for A, we'll take what we put here for A was 4a squared B. And what did we match that with? A squared B. That's a positive, so this is going to be an addition. How many a squared B's is that? 5, right? I have 4a squared B's here. I'm adding one more. When there's no number written, we know it's a 1. And so that means I have 5a squared B's all together. No, you mean like B squared? 2b? No, so that's a good question. So when we're adding or subtracting stuff with bases and exponents, it's like this is one whole thingamabob right here. And this is another thingamabob, right? So you're just saying I have 5 of those thingamabobs all together. You're not looking at the A or B separately. Now tomorrow when we multiply or divide, yes, we will be looking at each variable separately. But for addition and subtraction, it doesn't work like that. You just do the math on the coefficient, the number up front, and the rest of the stuff stays the same. So take a minute and finish out the rest of those. You're going to just combine the like terms that you matched in that section. And then think about if you're feeling like you could volunteer to come put your answers. Okay. Oh, or not okay. We have another moment.